Now let us discuss the important aspects of chemical bonding, that is hybridization. Hybridization. It is a very good aspect in chemistry as well as in biology. Now we will discuss hybridization from the point of view of chemistry. According to orbital, we know the orbital theory of covalence. Orbital theory of covalence. According to the orbital theory of covalence, let us see the electronic configuration of carbon atom, that is 1s2, 2s2, 2px1, 2py1, 2pz0. According to orbital theory of covalency, the number of half-filled orbitals of the carbon atom is 2. Therefore, the covalency of carbon atom must be 2. Covalency of carbon atom must be 2. But let us see the structure of methane, CH4, the tetrahedral structure of methane. There are 4 bonds of carbon. That means that the 4 hydrogen atoms are bonded with a carbon atom. This indicates the covalency of carbon atom is 4. The covalency of carbon atom is 4. But the orbital theory of covalency tells that the covalency of carbon atom is 2. But practically we found that from the structure of methane, for example, the covalency carbon atom is 4. Then how does this happen? We theoretically found that the covalency of carbon is 2 and practically found that covalency is 4. Both are correct. Orbital theory of covalency is correct, as well as the shape of methane molecule is also correct. Then how we explain this difference? This is a great challenge before the scientist to explain the two events. In order to account for this, scientists propose that this is the ground state of a carbon atom electron configuration: 1s2, 2s2, 2px1, 2py1, 2pz0. This is the ground state of electronic configuration. According to the scientist, the one electron from 2s orbital is excited to 2p vacant 2p0 orbital. That is, under excited condition, one electron from 2s orbital is excited to the vacant 2p0 orbital. That is, the configuration of carbon atom in excited state is equal to 1s2, 2s1, 2px1, 2py1, 2pz1. Hence, there are 4 vacant orbitals in the valence shell of carbon atom. There are 4 vacant orbitals, namely 2s1, 2px1, 2py1, 2pz1. Hence, according to orbital theory of covalency, the covalency of carbon atom is 4. This explains the tetravalency of carbon atom. This proposal explains the tetravalency of the carbon atom. But it is found that the 4 bonds of carbon is from 3 bonds from 2p orbitals and 1 bond from 2s orbitals. That is, we should get 2 types of bonds in methane molecule. That is, 3 bonds from p orbitals and 1 bond from s orbitals. We should get 2 sets of bonds in methane molecule. But it is practically found that the 4 bonds are equivalent. 4 bonds are equivalent. This is another problem arised before the scientist to explain it. Then how to explain? We should get two types of bond. One type of bond from the overlapping of three p orbitals, that is 2px, 2pz, and another from should get from 2s orbital. But instead of getting two types of orbital, we are getting four bonds which are equivalent. Hence, in order to explain this, scientists propose that these half-filled 4 orbitals, that is 2s and 3p orbitals, get intermixed. These orbitals get intermixed. As a result, no orbital has its own identity. That is, rather we are getting two types of orbital. We get the mixture of sp orbitals. That is, this process is called the hybridization. This process is called hybridization. That is, s orbital completely loses its identity, and p orbitals lost its identity. Rather, instead of getting separate orbitals, we are getting a special orbital which contain both s and p character. Thus, this entire process is called the hybridization of atomic orbitals. This concept started from hybridization. Let us define what is hybridization. It is defined as the redistribution of energy among the orbitals of same atom having equal or nearly equal energy. Hence, hybridization can be defined as the redistribution of energy among the orbitals of a same atom having equal or nearly equal energy. That is, it is a process of redistribution of energy among the orbitals of a particular atom having equal or nearly equal energy. And this process involves two steps. One is your excitation of the electron to the nearby vacant orbital. Second is intermixing of orbitals undergoing hybridization. This process involves two steps. The first step involves the excitation of the electron from one orbital to nearby vacant orbital, and second step, the vacant orbitals gets intermixed to give the hybrid orbitals. These two processes involves in the hybridization. This is the basic background or basic concept of the hybridization. Now, discuss what are the conditions required for hybridization. Conditions for hybridization. The conditions for hybridization. First important condition, the orbitals of a same atom undergo hybridization. The orbitals of same atom undergo hybridization. That means the hybridization takes place between carbon, nitrogen, chlorine, oxygen, same atom. The hybridization cannot take place between carbon, chlorine, nitrogen, oxygen, etc. The hybridization takes place, the orbitals of same atom undergo hybridization. The first condition. Second, the energy difference between hybridizing orbitals must be negligible. The energy difference between the hybridizing orbitals, that means the orbitals those are undergoing the process of hybridization, must be equal or nearly equal or negligible. If the energy difference between the orbitals is high, then no successful hybridization could take place. That means the 1s orbital or 2s orbital cannot hybridize 3p orbitals because the energy difference between 2s and 3p is very high. Hence, the hybridization between 2s and 3p orbital can take place. Therefore, the energy difference, the orbitals undergoing hybridization, that means the hybridizing orbital must be negligible. Third, the orientation of hybridizing orbitals must be same. The orientation of hybrid orbital must be same. That means the orbitals those are undergoing hybridization, the orientation of these orbitals must be same. That is, if one orbital is xy plane, then another orbital must be same plane. That is same xy. If one orbital is yz plane, then another orbital must be same yz plane. If orientation is not same, then successful hybridization cannot take place. These are three important conditions for the hybridization. That is, same orbitals of a same atom and energy difference must be negligible. Third, the orientation must be same.